In this lesson, we are going to calculate support reactions on structures. What are support reactions? Support reactions, these are what keep the structures at equilibrium. Now, if you take a look at the screen, we have two beams. The first beam is a simply supported beam, while the second beam is a cantilever beam. So let's take a look at the first beam. Now, as you can see, we're having a pin support at point A. We're having a roller support at point B. Pin support, they don't allow movement in the S and Y direction. While roller support, they don't allow movement in the Y direction. So we are going to have three unknown forces. Now you need to make an assumption on the direction of these forces. So we are going to say the forces in the Y direction is going to be acting upward, while the forces in the S direction is going to be to the right. These values, they are going to be positive. We are going to check if our assumption is correct or not. Whenever we have a negative value, meaning our assumption is wrong. But if we have a positive value, our assumption is right. So let's draw the unknown forces. So we're going to have an unknown force AY acting upward. Then we're going to have an unknown force AS to the right. While on roller support, we're going to have an unknown force BY. Now let's calculate these forces. As you can see, we don't have any horizontal force on this beam. Because we don't have any horizontal force on this beam, AS is going to be equal to 0 because we don't have any horizontal force. Now let's calculate AY and BY. We are going to take the summation of the moment at point A is equals to 0. So we are going to say the movement in the counterclockwise direction is positive, while the movement in the clockwise direction is negative. Now, you need to know that moment is equals to force times distance, meaning in order for us to have moment, or in order for moment to be produced, we need force and distance. Now, we are going to calculate BY. So we are going to say BY, which is the force, then multiplied by the distance. Now, the distance is going to be from the roller support at point B to the pin support at point A. So this is going to be 8 feet plus 12 feet plus 10 feet plus 10 feet. This is going to give us 40 feet. So this is multiplied by 40 feet. Now this is positive because if we apply a force upward, this beam is going to try to rotate in the counterclockwise direction. So we are going to have positive values. Now, what about AS and AY? AS and AY is going to be equal to 0 because there won't be any moment produced because we are taking the moment at point A. So because AS and AY is passing through point A, meaning there is no distance, and whenever there is no distance, meaning there won't be any moment produced. So this is equal to 0. Now we also have 3 vertical forces acting downward. So this is going to be, for the first force, we are going to have 20 kip. We are going to have 20 kip multiplied by the distance. The distance is going to be 10 feet, as you can see. Because this is going to try to rotate this beam in the clockwise direction, because if we try to apply a load on this beam, if we try to apply this load downward, this beam is going to try to rotate in the clockwise direction. So because it is rotating in the clockwise direction, it's going to be negative. So this is negative 20 kip, negative 20 kip, then multiplied by the distance, which is 10 feet. We also have 15 kip. So because this is acting downward and it is going to try to rotate this beam in the clockwise direction, it's going to be negative. So this is negative 15 kip, then multiplied by the distance. What is the distance from 15 kip to the pin support? This is basically 20 feet. So this is multiplied by 20 feet. Then the last force, which is 16 kip, this is also going to be negative 16 kip because this is acting downward and it's going to try to rotate this beam in the clockwise direction. Then multiplied by the distance. The distance is going to be 32 feet. So because we don't have any additional vertical force, this is equal to 0. Now we just need to solve for By. So if we solve for By, we are going to get By is equal to negative 25.3 kip. Now the unit is going to be in kip because we are dealing with force. So this is going to be in kip. So By is going to be negative 25.3 kip. As you can see, we are having a negative value. We are having a negative value which is negative 25.3 kip. Because we are having a negative value, meaning our assumption is wrong. Meaning this force is going to act downward because we are having a negative value. Whenever we have a negative value, the force is acting downward. And whenever we have a positive value, the force is acting upward. So meaning By is 25.3 kip and it is acting downward. So let's calculate Ay. So we are going to sum all the forces in the y direction. So we're going to say summation of all the forces in the y direction is equal to 0. So we're going to say all the forces acting in the upward direction is positive. So we are going to have 20 kip. 20 kip is acting downward. So meaning this is going to be negative. So this is going to be negative 20 kip. We're also having 15 kip, and this is acting downward. So it's going to be negative 15 kip. Then minus, we're also having 16 kip. So this is negative 16 kip. What about By? We know that By is acting downward. So this is going to be negative 25.3 kip. Now we are left with Ay, and Ay is acting upward. So this is going to be positive Ay is equal to 0. So we just need to find Ay. So if you calculate Ay, you are going to get Ay equal to 76.3 kip. So this is the value of Ay. As you can see, we are having a positive value. Because we are having a positive value, meaning this force is indeed acting upward. So meaning our assumption is correct. So the force is acting upward. So these are the forces that are required in order for this beam to be at equilibrium. The force AS is 0. By is 25.3 kip acting downward, while AY is 76.3 kip acting upward. So let's find the support reaction on the second beam. So we're having a cantilever beam and we're having a fixed support at point A. We know that fixed support, they don't allow any movement. So we're going to have 3 unknown forces. Now, like I said, we are going to assume the vertical force to be acting upward. So we're having AY, then the horizontal force acting to the right. So we're having AS. Now, for the moment, we are going to assume this to be in the counterclockwise direction. So this is going to be MA. So these are the forces we are going to calculate. Now, if you take a look at this, we are having an inclined force of 10 kip. So we need to decompose this force in its vertical and horizontal components. So how can we do this? If you take a look at this triangle, we are having the 3 as the adjacent, then we're having 4 as the opposite. So we need to calculate the hypotenuse. How can we calculate the hypotenuse? We are going to use Pythagoras theorem. So this is going to be hypotenuse is equals to the square root of 3 square plus 4 square. Calculating this, we are going to have the hypotenuse as 5. So this is going to be equal to 5. This is the y component, while this is the s component. Now we need to calculate the force. Now, for the y component, this is associated with opposites. So we are going to say 4 over 5, because the opposite is 4, then we need to divide this with the hypotenuse. So it's going to be 4 over 5, then multiplied by the force, which is 10 kip. So this is going to be 4 over 5 multiply 10 kip. So this is going to be the vertical force. Now what about the horizontal force? This is associated with the adjacent. So we're going to take the adjacent, which is 3. So this is going to be 3, then divided by the hypotenuse, which is 5. Then we're going to multiply this with the force, which is 10 kip. So this is going to be the horizontal component of this inclined force. Now we need to find AY, AS, and MA. Now we're going to say the summation of moments at point A is equals to 0. So we're going to take the counterclockwise direction to be positive, while the clockwise direction to be negative. Now, like I said, moment is equals to force times distance. If you take a look at this, AS and AY is passing through point A. This is going to be equal to 0 because we don't have any distance. Because AS and AY is passing through point A, meaning there is no distance, so meaning there won't be any moment produced. So AS and AY is going to be equal to 0. Now let's take a look at 20 kip. So 20 kip is going to try to produce a moment at point A. So because this is acting downward, meaning it's going to try to rotate the beam in the clockwise direction. And because we're having clockwise direction, it's going to be negative. So this is negative 20 kip, which is the force. We also need a distance. Now what is the distance? The distance is 20 feet. So this is going to be multiplied by 20 feet. Now let's take a look at the vertical force component. This is 4 over 5 multiplied 10 kip. This force is going to try to rotate this beam in the clockwise direction because it is acting downward. It's going to try to rotate it in the clockwise direction. This is going to be negative. So we are going to have 4 over 5, then multiply 10 kip. This is the force. We also need the distance. Now what is the distance? The distance is going to be 10 feet. So we are having multiplied by 10 feet. Now 3 over 5 multiplied 10 kip, which is the horizontal force component. This is going to produce no moment because this is passing through the point A. So we don't have any distance. So because we don't have any distance, meaning the horizontal force component is not going to produce any moment. Now we also have MA, which is the moment we are trying to determine. And as you can see, this is in the counterclockwise direction. So it's going to be positive. MA is equals to 0. Now we just need to calculate MA. So this is going to be negative 20 multiplied 20 is going to give us 400. So this is negative 400 kip feet. Then minus 4 over 5 multiplied 10 is going to give us 80. So this is negative 80 kip feet plus MA is equal to 0. Now negative 400 minus 80 is going to give us negative 480. So this is negative 480 kip feet plus MA is equals to 0. Now if we take this to the right side, we're going to have MA is equal to 480 kip feet. So the moment is going to be equal to 480 kip feet. Now because we have a positive value, meaning the direction of the moment is counterclockwise, let's calculate the other values. So let's find the force AY. How can we do this? We are going to take the summation of the forces in the y direction to be equal to 0. So we are going to say the forces acting upward is positive. As you can see, AY is upward, so this is going to be positive. So we're having positive AY. What about 20 kip? 20 kip is acting downward, so this is negative 20 kip. Now, what other vertical force do we have? We have 4 over 5 multiplied 10 kip, and this is acting downward, so this is going to be negative 4 over 5 multiplied 10 kip. So this is going to be AY minus 20 kip Then minus 4 over 5 multiplied 10, this is going to give us 8. So this is 8 kip is equal to 0. Now negative 20 minus 8 is going to give us negative 28. Now if we move negative 28 to the right side, we are going to have 28. So AY is equal to 28 kip. Now we are having a positive value. Because we're having a positive value, meaning the direction is upward. So let's calculate the value of AS. So we are going to take the summation of the forces in the S direction to be 0. And we're going to say the force acting to the right is positive, while the force acting to the left is negative. As you can see, we're having AS acting to the right, so meaning this is going to be positive, so this is AS. We're having 3 over 5 multiplied 10 kip acting to the left, so this is going to be negative. So this is negative 3 over 5, then multiply 10 kip. We don't have any additional horizontal force, so this is equal to 0. Now this is going to be AS minus 3 over 5 multiplied 10 is going to give us 6. So this is 6 kip is equals to 0. If we move negative 6 to the right side, we are going to have 6. So AS is going to be equal to 6 kip. As you can see, we are having a positive value. Because we're having a positive value, meaning the direction of this force is going to be to the right. Now, these are the forces that are required in order for this beam to be at equilibrium. In this lesson, we are going to solve more examples on support reactions on beams. Now, if you take a look at the screen, we have a beam, we have a pin support at point A, and we have a roller support at point B. We know that pin support, they don't allow movement in the S and Y direction, while roller support, they don't allow movement in the Y direction. Pin support, we are going to have 2 unknown forces, while on the roller support, we are going to have 1 unknown force. Now, what you need to do is you need to make an assumption on the direction of these forces. So we are going to say all the vertical force, we are going to assume this to be acting upward, while the horizontal force, we are going to assume this acting to the right. And if we have a positive value, meaning our assumption is right, but if we have a negative value, our assumption is wrong. They are acting in the opposite direction. So we are going to have AY, this is acting upward, while we are going to have AS, this is acting to the right. Now on the roller support B, we are going to have BY, so this is acting upward. So these are the forces we need to calculate. So these forces, they will make this structure to be at equilibrium. So how can we calculate these forces? Now what you need to know is, because we don't have any horizontal force on this beam, meaning AS is automatically going to be equal to 0, because we don't have any horizontal force on this beam. So we are going to say AS is equal to 0 because we don't have any horizontal force on this beam. Now all we need to do, we just need to calculate AY and BY. Now if you take a look at this, we are having a distributed load. As you can see, we are having a distributed load. So what you need to do is you need to replace it with an equivalent force. So how can we replace this with an equivalent force? All you need to do, you need to take the area of this rectangle. Now the area of this rectangle is going to be the height then multiplied by the width. So the width is going to be 8 feet, while the height, this is going to give us 20. So 20 multiply 8 is going to give us 160. So this equivalent force, this is going to be at the middle. So you need to place this at the middle because we are having a rectangle. So we are having a rectangle. So we are going to place this at the middle. So this is going to be 160. This is 160 kip. So this is the equivalent force Now we need to find AY and BY. So let's find BY. So what we need to do, we need to take summation of the moments at A. So we're going to take summation of the moment at A. So this is summation of moments at A is equal to 0. So we're going to say the movement in the counterclockwise direction is positive, while the movement in the clockwise direction is negative. Now, AS and AY, this is going to be equal to 0 because they are passing through the point of origin. They are passing through point A. And because we are taking moment at point A, meaning AS and AY is going to be equal to 0. Because we know that moment is equal to force times distance. In order for us to have moment, we need force and distance. Because AS and AY, they don't have any distance, meaning there won't be any moment produced at this point. Now, if you take a look at this, we have a moment of 10 cubic feet, and this is acting in the clockwise direction. So because this is acting in the clockwise direction, meaning this is going to be negative. So this is negative 10 cubic feet. Now what about 12 cubic? So if we apply a force 12 cubic, if we apply this force on this beam and this is acting downward, this force is going to try to rotate this beam in the clockwise direction. So because it is trying to rotate the beam in the clockwise direction, we are going to have negative. So this is negative 12 cubic. Then multiply, what is the distance? The distance is going to be 7 feet plus 4 feet. So this is the distance from this force to the pin support. So 7 plus 4, this is going to give us 11. So this is 11 feet. Now what about BY? As you can see, BY is acting upward. If we try to apply this force on the beam and this is acting upward, it is going to try to rotate this beam in the counterclockwise direction. So we are going to have positive. So this is positive BY. Then what about the distance? So the distance from BY to point A, this is going to be 7 plus 4 plus 7. So this is going to be 18. So this is 18 feet. Now we have the equivalent force, 160 kip, and this is acting downward. So because it is acting downward, meaning it is going to try to rotate the beam in the clockwise direction. So this is going to be negative 160 kip. So we also need the distance because we want to find the moment produced at point A due to the force 160 kip. So what is going to be the distance? As you can see, the distance from the equivalent force 160 kip to the roller support, this is going to be 4 feet, right? This is 4 feet. So it's going to be 4 feet plus 7 feet plus 4 feet plus 7 feet. This is going to give us 22 feet. So we're going to have multiplied by 22 feet. So because we don't have any additional force, this is going to be equal to 0. So all we need to do, we just need to find BY. We just need to solve BY. So it is very easy now. All you need to do, you just need to use your calculator to solve for BY. So solving for BY, you are going to get BY is equal to 203.44 kip. So this is going to be the value of BY, 203.44 kip. As you can see, BY is positive. So because it is positive, meaning our assumption is correct. So meaning this is indeed acting upward because we're having a positive value. So let's solve for AY. How can we solve for AY? We need to take the summation of the forces in the vertical direction. So we need to say this is equal to 0. So I'm going to say summation of the forces in the y direction is equal to 0. And I'm going to say the force is acting upward is positive, while the force is acting downward is negative. Now, the first force we have is AY. As you can see, AY is acting upward, so this is going to be positive. So we're going to have AY. Now, the next force is 12 kip, and this is acting downward. So because it is acting downward, we are going to have negative. So this is negative 12 kip. What other forces do we have? We have BY, and BY is 203.44 kip, and this is acting upward, so it's going to be positive. So this is positive 203.44 203.44 kip. Now we have 160 kip. This is the equivalent force. 160 kip is acting downward, so it is going to be negative. So this is going to be minus 160 kip. So because we don't have any additional force, meaning this is going to be equal to 0. So we're going to have AY, then minus 12 kip plus 20.44 kip minus 160 kip. This is going to give us positive. This is going to give us positive 31.44 kip is equal to 0. So if we take this to the right side of the equation, we're going to have AY is equal to negative 31.44 kip. So this is going to be the answer. So AY is negative 31.44 kip. As you can see, we are having a negative value. Because we have a negative value, meaning our assumption is wrong. Meaning this force is acting downward because we are having a negative value. So AS is 0 because we don't have any horizontal force. BY is 203.44 kip and this is acting upward. YAY is 31.44 kip and this is acting downward. So these are the forces that are required in order for this beam to be at equilibrium, because support reactions, these are what keep the structures at equilibrium. Now we're going to take a look at another example. As you can see on the screen, we have a beam. Now on this beam, we have a roller support at point A and we have a pin support at point B. So meaning at point A, we are going to have one unknown force. So this is AY. As usual, we are going to assume this to be acting upward, while at point B, we are going to have two unknown forces. So this is BY acting upward, while BS to the right. So we are going to assume this direction. Now, if you take a look at the distributed load, we have a complicated looking load. But don't worry, all you need to do is you need to decompose this load. How can we decompose this load? If you decompose this load, you are going to have a rectangle with a triangle. So we are going to have a rectangle with a triangle. As you can see, we are having a big rectangle with a small triangle. Now, what you need to do is you need to replace this distributed load. You need to replace this with an equivalent force. Now, we are going to have two forces. On the rectangle, we are going to have an equivalent force, F1, and this is going to be at the middle because we are having a rectangle. So this is going to be at the middle. So we are going to have this equivalent force at the middle. So this is F1. While we are also going to have an equivalent force, F2, on this triangle. So this is going to be F2. Now, we need to calculate these forces. So how can we calculate this? We are going to take the area of the triangle and the area of the rectangle. So the area of the rectangle is going to be 22 feet because this is the length of the rectangle. Then multiply by the height, which is 0.05 kip per foot. So this is going to be 22 multiplied by 0.05. This is going to give us 11 kip. So F1 is equal to 11 kip. So this is the force. Now we also need to calculate. We also need F2. Now how can we calculate F2? We just need to find the area of this triangle. The area of this triangle, as you can see. So this is going to be 11, then multiply by the height of this triangle is going to be 0.02 because 0.07 minus 0.05 is going to give us 0.02. So this is the height of the triangle. So this is 0.02. So this is 0.02 multiply 11, then divided by 2. This is going to give us 0.11 kip. So F2 is equal to 0.11 kip. So this is the second force. Now you need to know that F2, the distance from F2 to the left of the triangle is going to be 1/3 of the length. So this is going to be 1/3 of the length. So this is 1/3. While from the force F2 to the right of the triangle, this is going to be 2/3. So this is 2/3. Now what we need to do, we just need to calculate AY, BY, and BS. Now you need to know that BS is going to be equal to 0 because we don't have any horizontal force on this beam. So BS is automatically equal to 0 because we don't have any horizontal force. So let's calculate for AY and BY. Now we are going to take the moment, summation of the moment at point B, because we want to find AY. So we're going to take summation of moment at point B, at the pin support. So we're going to say summation of moment at point B is equal to 0. So we are going to say the movement in the counterclockwise direction is positive, while the movement in the clockwise direction is negative. So the first force is AY, and because AY is acting upward, and if we apply a force upward, it's going to try to rotate this beam in the clockwise direction. So because it is clockwise, meaning we are going to have a negative value. So this is negative AY. Then we also need the distance. What is the distance? The distance is going to be 11 plus 11, which is 22 feet. So this is the distance from AY to the pin support. So this is 22 feet. So this is multiplied by 22. Now we have F2. As you can see, F2 is 0.11 kip. And this is acting downward. Because this is acting downward, it is going to try to rotate the beam in the counterclockwise direction. So because it is counterclockwise, meaning it is positive. So this is positive 0.11 kip. We also need the distance. So what is the distance? The distance is going to be 2/3 of 11 feet plus 11 feet. So 2/3 of 11 feet plus 11 feet, this is going to give us 18.3 feet. So this is multiplied by 18.3 feet. Now what about F1, 11 kip? If we applied a downward force, 11 kip on this beam with relative to this point B, it is going to try to rotate this beam in the counterclockwise direction. And because this is counterclockwise, meaning it is positive. So this is positive 11 kip, then multiply by the distance. So what is the distance? The distance is going to be 11 feet. So this is 11 feet from the force to the pin support. So this is multiplied by 11 feet. So because we don't have any additional force, meaning this is equal to 0. So what we need to do, we just need to find AY. So if you use your calculator, you're going to get AY is equal to negative 11.09 kip. So this is going to be the value of AY. So AY is equals to negative 11.09 kip. As you can see, we are having a negative value. Because we're having a negative value, meaning our assumption is wrong, meaning this force is acting downward because we are having a negative value. So let's find the remaining force, BY. Now how can we find BY? We are going to say summation of the forces in the vertical direction is equal to 0. So this is going to be summation of the forces in the vertical direction, Fy, is equal to 0. So we're going to say all the forces acting upward is positive, while all the forces acting downward is negative. So the first force we have is AY. As you can see, AY is negative 11.09 kip, and this is acting downward. So this is going to be negative 11.09 kip. Then the next force we have is F2, which is 0.11 kip, and this is acting downward, so negative 0.11 kip. Then the next force is 11 kip. As you can see, this is acting downward, so this is going to be negative 11 kip. Then the next force we have is By. This is what we want to find, and it is acting upward, so this is going to be positive. So this is positive By. Because we don't have any additional vertical force, this is equal to 0. So all we need to do, we just need to solve for By. So negative 11.09 minus 0.11 minus 11. This is going to give us negative 22.2. So this is negative 22.2 kip plus By is equal to 0. So all we need to do, we just need to take this to the other side of the equation. So this is going to be By is equal to 22.2 kip. So By is equal to 22.2 kip. So this is the force. As you can see, we are having a positive value. So because we are having a positive value, meaning our assumption is right. So meaning this force is acting upward. So these are the forces that are required in order for this beam to be at equilibrium. Bs is 0, Ay is 11.09 kip and it is acting downward, while By is 22.2 kip and it is acting upward. Now, if you want to check if your answer is correct, there is a quick way you can check if your answer is correct. All you need to do, you need to take the summation of all the forces needs to be equal to 0. If it is equal to 0, meaning your answer is correct. Let's quickly do the check. We're going to say summation of all the forces in the y direction need to be equal to 0. So the first force we have is Ay, and Ay is negative 11.09. So this is negative 11.09 kip. Then the next force is 0.11 kip, as you can see, and this is downward, so meaning this is negative. So this is negative 0.11 kip. Then the next force we have is 11 kip, and this is acting downward, so this is negative 11 kip. Then the next force we have is By, and By is positive, and By is positive, it is acting upward, so this is positive 22.2 kip. So we need to make sure this is equal to 0. So let's calculate this. So this is negative 11.09 minus 0.11 minus 11 plus 22.2. So this is indeed equal to 0. So because this is equal to 0, meaning our calculation is correct. So these are the forces that are required to keep this structure at equilibrium. So if you enjoyed this video, don't forget to give this video a thumbs up and subscribe to the channel. Also, if you have any question, make sure you ask me any question in the comment section below. Thank you. This lesson is going to be a bit long because if you take a look at the screen, we are having a long span beam that has one pin support at point A and 3 roller supports, one at point B, one at point E, and one at point F. So we are going to have 5 unknown reactions. Now, I know you might be thinking that this is going to be a statically indeterminate structure, but because we have 2 hinges, as you can see, we have one hinge at point C and we have another hinge at point D. So this is going to reduce the degree of indeterminacy from 5 to 3. So these hinges, they are going to make this beam a statically determinate beam. Now, what we're going to do is we are going to assume the direction of this support reaction.
we are going to say all the vertical forces is acting upward, while all the horizontal forces is acting to the right. So at point A, we are going to have AY, this is acting upward. Then we are going to have AS, this is acting to the right. Then at point B, because it is the roller support, we are going to have just one support reaction. So this is BY acting upward. At point E, we are going to have EY acting upward. Then at point F, we are going to have FY acting upward. So these are the support reactions we need to calculate. Now you need to know that AS is going to be automatically equal to 0 because we don't have any horizontal force on this beam. So we're going to say AS is automatically equal to 0 because we don't have any horizontal force on this beam. So we need to calculate the remaining support reactions. Now, how can we calculate the support reactions? Now, we are having a distributed load of 2 kip per foot that is applied on this beam. If we try to use summation of moments at any point, or maybe we try to say all the vertical forces acting upward is 0, we won't be able to calculate these forces because they are too much. We have AY, BY, EY, and FY. So we need to use another method, or we need to use another way to calculate these support reactions. Now, how can we calculate this? This is the reason we have hinge on this beam. So we are going to use this hinge to evaluate these support reactions. Now, we are going to make a section, or we're going to cut a section at the hinge. So we're going to cut a section either at D or C. Now, if you cut a section at point D and you look to the right, we are still going to have 2 unknown forces. We are going to have EY, FY, and we're also going to have an unknown internal forces. So we are going to have an unknown vertical force, unknown horizontal force, and unknown bending moment. So we won't be able to calculate this if we look at the right. Also, if you look at the left, we won't be able to calculate AY and BY because we're also going to have unknown internal forces. Now, what do we need to do? What we need to do is we need to make a segment, or we need to make a section at point C and D. So we are going to make a section at point C. We're also going to make a section at point D. So we are going to evaluate this section. So we are going to evaluate CD. Then we are going to calculate the internal forces inside the beam. So let's calculate this. So if we make a section at point C and D, we are going to have something like this. So this is point C and this is point D. So we know we are having a distributed load. We are having a distributed load of 2 kip per foot. So this is distributed load 2 kip per foot. Now we need to resolve this as point load, and we know the distance. This distance is 120 feet. So this is 120 feet. So we need to resolve this as a point load. How can we resolve this? We are going to take the area of this rectangle. So it's going to be 2 multiply 120. So this is going to give us 240. So this is going to give us 240. So the point load is going to give us 240 kip. And this is going to be at the middle. So we are going to have this as the middle. So we are going to have 60. So this is going to be 60 feet. Then we know we're also having 100 kip. As you can see, we're also having 100 kip applied on the beam. So we're having 100 kip here. So this is 100 kip. And this 100 kip, this is located 30 feet from point C. So this distance is 30 feet. So now we are also going to have unknown internal forces on this beam because we made a section at point C and point D. So we are going to have an unknown vertical force CY because we don't have any horizontal force on this beam. So the unknown horizontal force, or the unknown internal horizontal force, is going to be equal to 0. Also, we know that moment at hinge is equal to 0, so we don't have any moment. So at point D, we're also going to have dy. This is starting upward. So we're going to calculate cy and dy. Now, how can we calculate this? We are going to take the summation of moments at any point. Let's take the summation of moments at point C. So we're going to say summation of moments at point C is equals to 0. We're going to assume all the movement in the counterclockwise direction to be positive, while all the movement in the clockwise direction to be negative. So if we apply 100 kip on this beam with relative to point C, it is going to try to rotate this beam in the clockwise direction. So this is going to be negative. So this is negative 100 kip, then multiply by the distance. What is the distance? As you can see, the distance is 30 feet. So this is going to be multiplied by 30 feet. Then also we are having 240 kip, and this is acting downward. So if we apply 240 kip on this beam with relative to the point C, it's going to try to rotate this beam in the clockwise direction. So this is negative. So this is negative 240 kip, then multiply by the distance. So what is the distance? The distance is 60 feet, as you can see. So this is going to be multiplied by 60 feet. Then what about dy? Dy is acting upward. So if you apply this force on this beam with relative to point C, it's going to try to rotate this beam in the counterclockwise direction. So this is going to be positive. So this is positive dy, then multiply by, what is the distance? The distance is 120 feet, as you can see. So this is going to be multiplied by 120 feet. So because we don't have any additional force, this is equal to 0. So if you calculate dy, you are going to get dy is equal to 145 kip. So dy is equal to 145 kip. Now, because we're having a positive value, meaning this is acting upward, because we're having a positive value. So what we need to do, we need to find Cy. How can we calculate Cy? We just need to take the summation of the forces in the vertical direction equal to 0. So I'm going to say summation of the forces in the vertical direction is equal to 0. I'm going to say all the forces acting upward is positive, while all the forces acting downward is negative. As you can see, Cy is upward, so this is going to be positive. So this is going to be Cy. Then 100 kip, this is acting downward, so this is going to be negative. So this is negative 100 kip. Then 240 kip, this is 240 kip, this is acting downward, so this is also going to be negative. So this is negative 240 kip. Then we are having dy. Dy is 145 kip, and this is acting upward, so this is going to be positive. So this is positive 145 kip. So because we don't have any additional force, this is equal to 0. So all we need to do, we just need to calculate for Cy. Now if you calculate Cy using your calculator, you're going to get Cy is equal to 195 kip. So Cy is equal to 195 kip. And as you can see, this is a positive value, so meaning this is acting upward. So these are the internal forces. Now, what you need to do is you now need to look at either segment ABC or segment DEF. Now, we already know the internal forces. You need to know that these internal forces, these are not the support reaction. These are not included in the structure. We calculated for this because we want to calculate for the support reaction, because if we don't know the internal forces, we won't be able to calculate for this support reaction. So this is the reason we calculated for the internal forces. Now we know the internal forces, we are now going to use this to calculate the support reaction. So what we are going to do now is we are going to take a look at segment ABC. Now we know the internal force. We're now going to take a look at segment ABC so that we can calculate BY and AY. So we're going to say, take a look at segment ABC, or we're going to say, make a section at point C and look to the left. So we're going to write this as segment ABC. Now, segment ABC, if you take a look at this, we are going to have something like this. So this is the pin support, and we are having AY. This is acting upward, and we know AS is equal to 0. So we are having a roller support at point B. So this is BY acting upward. Then this is the distributed load. So this is the distributed So this is the distributed load, and the distributed load is 2 kip per feet. 2 kip per feet. Now this is the point. Now this is the point C, as you can see. So we need to resolve this distributed load as point load. How can we do this? We just need to take the area, and we know this distance. This distance is basically 100 plus 90, which is going to give us 190 feet. And we know this is from A to B. This is 100 feet. This is 100 feet. Then from B to the point C, this is 90 feet. This is 90 feet. So 2 multiply 190, this is going to give us 2 multiply 190, this is going to give us 380. So the resultant force is going to be 380 kip. So this is 380 kip, and this is going to act at the middle. So we are going to have this as 95 feet because it is acting at the middle. Now all we need to do, we just need to calculate for AY and BY. And you need to know that because we calculated CY, which is internal force, we calculated CY to be 195 kip. Now if we take a look at segment ABC, this is going to act downward because to the right of ABC, this is acting upward, as you can see. So to the left of ABC, it is going to act downward in order for us to satisfy equilibrium, because when we calculated for CY using CD, we got 195 kip, and this is acting upward. Now looking at segment ABC, this is going to act downward so that equilibrium can be satisfied. So this is going to be 195 kip. So this is going to be 195 kip, and this is acting downward because the forces are same, but they are in opposite direction. So what we need to do, we just need to calculate for AY and BY. So we are going to say summation of the moment at point A is equal to 0. So let's take moment at point A equal to 0 so that we can calculate for BY. So I'm going to say summation of moments at point A is equal to 0, and I'm going to take all the movements in the counterclockwise direction to be positive, while the movement in the clockwise direction to be negative. So this is going to be 380 kip. If we apply 380 kip on this beam, and this is acting downward with relative to point A, it is going to try to rotate this beam in the clockwise direction. So this is going to be negative. So this is negative 380 kip. Then multiply by the distance. What is the distance? The distance is 95 feet, as you can see. So this is going to be multiplied by 95 feet. Then we have BY. BY is acting upward. If you apply this on this beam with relative to point A, it is going to try to rotate this beam in the counterclockwise direction. So this is going to be positive. So this is positive BY. Then multiply by the distance. What is the distance? The distance is going to be 100 feet. As you can see, this is 100 feet from point A. So this is going to be multiplied by 100 feet. Then we have 195 kip, and this is acting downward. This is going to try to rotate the beam in the clockwise direction. So this is going to be negative. So this is negative 195 kip. Then multiply by the distance. So what is the distance? The distance is going to be 100 feet plus 90 feet, which is going to give us 190 feet. So this is multiplied by 190 feet. So we don't have any additional force, so this is equal to 0. So all we need to do, we just need to calculate for BY. So if you use your calculator, you're going to get BY is equal to 731.5 kip. So BY is equal to 731.5 kip. As you can see, this is a positive value, so meaning our assumption is correct. This is indeed acting upward. So we're going to take summation of all the vertical forces equal to 0. So we're going to say summation of all the vertical forces is equal to 0, and we're going to say all the forces acting upward is positive, while all the forces acting downward is negative. So what is AY? We don't know AY. This is what we want to calculate. So this is AY, and this is positive because it is acting upward. we're having 380 keep. This is going to be negative because it is starting downward. So this is 380 keep. Then we are having BY. We calculated BY to be 731.5 keep, and this was acting upward. So this is going to be positive. So this is positive 731.5 keep. Then we have 195 keep, and this is acting downward. So this is going to be 1 minus 195 keep. So we don't have any additional force, so this is equals to 0. So all we need to do, we just need to calculate for AY using our calculator. So AY is going to be equal to negative 156.5 keep. So this is the value of AY. As you can see, we are having a negative value. Because we are having a negative value, our assumption is wrong. This is acting downward because we're having a negative value. Now we know the value of AY, we know the value of BY, and we know AS. AS is equals to 0. So we are left with just EY and FY. So how can we calculate for EY and FY? So what we are going to do is we are going to take a look at this other segment. We are going to take a look at segment DEF because we want to calculate for EY and FY. So let's take a look at this segment. Now, if you take a look at segment DEF, we are going to have something like this. So we're having a pin support at point, we're having a roller support at point A. Then we're having another roller support at point F. So this is EF acting upward. This is FY acting upward. Then this is the hinge at point D. So we also have a distributed load of 2 keep per feet. So this is the distributed load of 2 keep per feet. Now we know this distance is the distance from point D to E. This is 90 feet, as you can see. Then the distance from point E to point F, this is 100 feet. Yeah, this is 100 feet. So we need to resolve these 2 keep. We need to resolve this distributed load of 2 keep per feet. We need to resolve this as a point load. So we're going to take the area of the rectangle. So this is going to be 2 multiply 190. So 2 multiply 190, this is going to give us 380. So this is going to be 380 keep. So we're going to have 380 keep, and this is going to act at the middle of the rectangle. So we know we are going to have an unknown internal force, and we calculated for this unknown internal force, which was dy. We calculated this value to be 145 keep, and this was acting upward. Because we are taking a look at DEF, this is going to act downward because the forces are similar, the forces are same, but they are opposite. Because we need this value to be opposite so that our beam is going to be at equilibrium. That is, the internal forces is going to be at equilibrium. So because the value is 145 keep and it is acting upward, and we want to take a look at DEF, this is going to act downward in order for this beam to, or in order for the internal forces to be at equilibrium. So this is going to be 145, if I'm right. Yeah, 145 keep. So this is 145 keep, and this is acting downward. So what we need to do, we just need to calculate EY and FY. Let's take summation of moments at point F so that we can calculate EY. So this is going to be summation of moments at point F is equal to 0. And we're going to say all the movements in the counterclockwise direction is positive, while all the movement in the clockwise direction is negative. So as you can see, we're having 145 keep, and this is acting downward. If we apply this on this beam with relative to point F, it's going to try to rotate this beam in the counterclockwise direction. So we are going to have a positive value. So this is going to be 145, then multiply by the distance. The distance is going to be 190 feet, as you can see. So this is going to be 190 feet. Then we have AY, and AY, this is acting upward. If we apply this on this beam with relative to point F, it's going to try to rotate this beam in the clockwise direction. So this is going to be negative. So this is AY, then multiply by the distance. So what is the distance? The distance is going to be 100 feet. As you can see, this is from AY to point F. So this is going to be 100 feet. So this is multiplied by 100 feet. Then we have 380 kip, and this is acting downward. If we apply this on this beam with relative to point F, it is going to try to rotate this beam in a counterclockwise direction. So we're going to have a positive value. So this is positive 380 kip. So we also need the distance because moment is equals to force times distance. So what is it? What is the distance? The distance is going to be 95 kip because this is at the middle of the rectangle. So it is going to be 95 kip. So this is multiply by 95 feet, not kip. I'm sorry for that. This is 95 feet because this is a distance. So it's going to be in feet. So this is multiplied by 95 feet. Then we don't have any additional force. So this is equal to 0. So all you need to do, you just need to use your calculator to calculate for AY. It is very easy now. Just use your calculator to calculate for AY. So if you calculate for AY, you're going to get AY is equal to 636.5 kip. So this is going to be the value of AY. So AY is 636.5 kip. Now, as you can see, this is a positive value, so meaning this is acting upward. Our assumption is correct. Now, we are left with just Fy, so we are going to calculate Fy. Now, how can we calculate Fy? We are going to take the summation of all the vertical forces equal to 0. And we are going to say all the vertical force acting upward is positive, while all the vertical forces acting downward is negative. So this is going to be 145 kip is acting downward, so this is going to be negative. So this is negative 145 kip. Then we're having 380 kip. 380 kip is acting downward, so this is going to be negative. So this is negative 380 kip. Then we have EY, and we calculated EY to be 636.5 kip, and it was acting upward. So this is going to be positive because it is acting upward. So this is positive 636.5 kip. Then we are left with Fy. This is what we want to calculate, and this is acting upward, so this is going to be positive. So this is positive Fy. We don't have any additional vertical force, so this is equal to 0. So all you need to do, you just need to calculate Fy. If you calculate Fy, you're going to get Fy is equal to negative 111.5 kip. So this is going to be the value of Fy. As you can see, we are having a negative value. So because we're having a negative value, our assumption is wrong. This force is acting downward. So these are the forces. So these are the support reactions. Now we need to write a summary of these support reactions. So let's quickly write a summary. So we're going to say summary. Now the first force AS, this is equal to 0 because we don't have any horizontal force on this beam. And AY, we calculated AY as 156.5 kip, and this was acting downward. Then we calculated BY as 731.5 kip, and this was acting upward. Also, we calculated EY as 636.5 kip, and this was acting upward. Then lastly, we calculated Fy as 111.5 kip, and this was acting downward. So these are the support reactions that are going to keep this structure at equilibrium. So these support reactions, this is what we need in order for this beam to be at equilibrium. Now, if you want to make a quick check, let's say you want to check if your answer is correct or not, what you're going to do is you are going to take the summation of all the vertical forces need to be equal to 0, or the summation of all the horizontal forces need to be equal to 0, or summation of all the moments needs to be equal to 0. Now, if you can prove this, meaning your answer is correct, meaning your calculations is correct. So let's quickly make a quick check. So let's take all the forces, that is all the vertical forces. Let's say this is equal to 0. So let's try to prove that this is indeed equal to 0 by taking all the vertical forces equal to 0. So if we can get all the vertical forces equal to 0, meaning our calculation is correct. So what you need to do is you need to decompose, or you need to resolve this 2 kip per foot as a point load. Now, how can we do this? This is a big rectangle, as you can see. So this is going to be 2, which is the weight, then multiply by the length. Now, what is the length? The length is going to be this distance. So this is going to be 100. This is 100 plus 90 plus 120 plus 90 plus 100. Now, if you calculate this, you are going to get 500. So 500 multiplied 2, this is going to give us 1000. So we are going to have a point load of 1000 kip, and this is acting at the middle. So let's calculate this. Let's see if we are going to get 0 or not. So I'm going to say summation of all the vertical forces need to be equal to 0. And all the vertical forces acting upward is positive, while all the horizontal forces, while all the vertical forces acting downward is negative. Pardon me. So we are going to say the first force we have, that is the first vertical force we have, is 156.5 kip. This is acting downward, so this is negative. So this is negative 156.5 kip. Then the next vertical force we have is By, and By is 731.5 kip. This is acting upward, so this is positive. So this is positive 731.5 kip. Then the next vertical force we have is 100 kip. This is acting downward, so this is negative. So this is negative 100 kip. Then the next force we have is 1000 kip. This is acting downward, so this is negative. So this is negative 1000 kip. Then the next force we have is Ay. As you can see, Ay is acting upward, so this is going to be positive. So this is positive 636.5 kip. And now lastly, we have Fy, which is 111.5 kip, and this is acting downward, so this is negative. So this is negative 111.5 kip. Now, this needs to be equal to 0. If it is equal to 0, our calculation is correct. But if it is not equal to 0, our calculation is wrong. So let's quickly calculate this. 156.5 plus 73.5 minus 100 minus 1000 plus 636.5 minus 111.5. Indeed, this is going to be equal to 0. As you can see, this is equal to 0, so meaning our calculation is correct. Because if you think of it, we always want our structure to be at equilibrium. We want this beam to be at equilibrium. How can we make this beam to be at equilibrium? We need the support reactions. We need the vertical support reactions to balance the force. That is the forces that are applied on the beam. So we need the support reactions to counteract these forces. Now, if we have the final answer to be 0, meaning the support reactions is in equilibrium with the applied load that is applied on the beam. But if we have a different value, meaning this beam is not at equilibrium, because in order for this beam to be at equilibrium, the support reaction needs to counteract the applied load. So this is the reason we always want our value to be 0, because this means our structure is at equilibrium. So this is the final answer.